So, for the most part, this lesson is going to be talking about the law of sines. There is an application to SOHCAHTOA and law of sines for finding area of a triangle where you don't know your base and your height. Here we have our base, but you remember your height would have to be perpendicular and go straight up through here. We don't know that. You could go ahead and use this formula to find your area. This formula only works if you have an angle between two sides you know. Here we have an angle between the two sides we know, so we can go 1/2 your first side times your second side times the sine of the angle in between them. And then we can type that in, making sure you're in the degree mode, and we would get this. And then it should be, since we have units here, centimeters squared. Similarly, over here, we have an angle between two sides. We know both of those sides, so we can go 1/2 our first side times our second side times the sine of the angle in between, and then we would get our answer. And because we have meters, it should be meters squared. So now let's get on to dealing with the law of sines. Now, the law of sines is really either the first equation or the second equation here. It doesn't make a difference which one. So you could use this, or you could use this. But in either case, you only use two of the three fractions. So you'll notice the green is just really the yellow that's flipped upside down. So to use the law of sines, you need to know an opposite pair. So that would mean you would need to know an angle and its side opposite, either the angle A, which is capital, and lowercase a, which is opposite, or you would need to know angle C and the side opposite, or you would need to know angle B and its opposite side. Notice, angles are capital letters, sides are lowercase letters. So if you know an opposite pair, an angle and its side opposite, you can use law of sines. Now, since it can be either one of these, whatever it is I'm looking for, I like to have it on top. So if I'm looking for a side, I'm going to put my sides on top. If I'm looking for an angle, I'm going to use this one over here and put angles on top. It just saves me an extra step in the process of solving the problem. Now, a side note here, once you get into dealing with the law of sines, you sometimes have to be concerned about how many triangles are formed. Now, if you have side, 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 or side, angle, or angle, side, angle, or angle, angle, side, which are all ways to prove triangles congruent from geometry, you don't have to even be concerned about this. But if you are dealing with what's referred to as a side, side, angle situation, where your angle is not between your two sides, then you have to be concerned about how many triangles are formed. Because we have this angle we know it's opposite side, and we have adjacent side. This angle we don't know. It, for the most part, could act like a hinge. It is possible, with this side swinging back and forth, that this opposite side is too short to form a triangle. Then it's no solution. It is possible, since this side can swing, that it would swing and just touch once. And that's what we would have here. It is possible, since this side is like a hinge, it would work once to be out here, and so you'd have a triangle like this. Or you could go ahead and rotate that side over here, and then you would have this triangle here. Either one, but in that case you'd have two. Or if this opposite side is really, really big, bigger than your adjacent side, well, then it's just one triangle. Now, that's if you have an acute angle, an angle that's less than 90. If it's a right angle or obtuse, basically if it's an obtuse, the only way it's going to form a triangle is if the opposite side's bigger than your adjacent side. So all that is summarized down here in these formulas. So could you refer back to this big diagram? Yes. But what we have right here summarizes what we were just talking about. So here we have an angle, another angle, and a side. So first of all, I'm going to draw my diagram. I threw in my two angles, and I have the side opposite of angle A. So I could use law of sines because I know my opposite pair. But I don't have to be concerned about how many triangles are here because this is an angle, angle, side. I only have to be concerned if it's a side, side angle. I don't have that, so I just have to go ahead and solve it. So to work this out, I have my opposite pair. I cannot find angle C, or I could find angle C, but I'm not going to use that yet. And I can't do C, side C, because I don't know angle C yet. So I'm going to go ahead and find side B. So I'm going to put B on top, side B, over the sine of the angle opposite of B, which, oh, sorry, here's my B, here's the sine of what's opposite of B. What I had here on the left was my opposite pair. I put a side of B on top, so I put my side that I know on top over the sine opposite. Now I got to get B by itself, so to get rid of dividing by sine 41, I'd want to multiply both sides by sine 41. This is my calculator ready form, then I type it into my calculator. Because I know two angles here, I can easily find the third angle by just subtracting them from 180. And I get 16. Now I could go ahead and use law of sines to be able to get side C. Since I'm looking for a side, I'm going to put that on top again. So I'll go C, side C, over angle sine of angle C equals what I knew to begin with, my opposite pair of 10 over the sine of 123. Then to get C by itself, I'd have to get rid of this right here, dividing by that, so I'm going to multiply both sides by that. This is my calculator ready form. I type it in and I get my answer. So first of all, I'd start out by drawing myself a diagram. You'll notice here I have a side followed by a side and then an angle, so it's not in between. So it's a side-side angle. Whenever you have a side-side angle, you have to check to see how many triangles you have. So here's our rules of what we have. So you'll notice our opposite is 5, our adjacent is 10. So I'm not going to be concerned about the top one. And by the way, I'm only dealing with number 1 here because it's acute, which is 25. I'm not going to look down here for obtuse, which is greater than 90. I'm not going to deal with this one because opposite of 5 is not greater than adjacent, so I don't even have to be concerned about that. These next two down both have opposite and adjacent sine of the angle. So I'll throw my opposite in of 5, go adjacent of 10, sine of my angle. I don't know that, so I'll type this in my calculator. I get 5 and then 4.23. Obviously, it's not this one here where it has an equal sign. Our opposite of 5 is not less than this. So therefore, it's got to be the next one down, which is 2 triangles. So I'm going to draw this out. One triangle will look like this. But since this top angle up here, which we don't know, kind of acts like a hinge, I could take this side here and flip it over here. And if that's the case, I would have this here, where once again, that top angle acts like a hinge, and that would be this. So these are the two triangles I'm going to have. Notice between the two triangles, I have the 25 over here, adjacent is 10 on each one. My opposite of my angle A is 5 on each one. So both of them fit that situation. So the first thing I can do here is find angle B. I don't know either one of the C's, so I can't find C. So if I'm looking for angle B, I'm going to go the sine of my opposite pair of 25 over the side opposite equals the sine of my angle B over its opposite side. As I said before, I like to put what it is I'm looking for on top. So I'm looking for an angle, so I put the angles on top. Now I need to go ahead and get B by itself. So I'd have to get rid of the 10 and multiply both sides by 10. then I'd have to get rid of the sine, so I'd have to inverse sine this. So I'd have inverse sine of that whole fraction. That would be angle B. That's my calculator ready form. I type it in and I get my answer. Now I know my first angle is 25. My second angle I just figured out is 57.7. Now I could either easily go ahead and get angle C by subtracting from 180, both the angles that I know, and I get 97. So if this angle is 97, I can use the law of sines to help me find my third side. Now, just as a side note, I cannot use the Pythagorean theorem here because it's not a right triangle. So that's why I have to use law of sines. So since I'm looking for an opposite, or given an opposite pair, and I'm looking for a side, I'm going to go the side over the sine opposite. So my C over the sine of angle C of 97.3 equals the opposite pair I was given, my side over the sine opposite. Now to get C totally by itself, I got to get rid of that dividing of 97.3, so multiply both sides by 97.3. I now have my calculator ready form. I can type it in and get my answer. Now, how do we go about dealing with the second triangle? Well, everything I started out with over here, of my two sides of my angle, I have over here on the right. But it's important to note that whatever you had for B here, this one is supplementary. So to find it, you go 180 minus that. Now, angle B, once again, was 57.7 from over here. So I throw that in, and I get 122.3. So if this angle is 25, this is 122.3, I could easily get my third angle by subtracting from 180. So 180 minus each one of those, and I get my 32.3. Now I could go ahead and do law of sines with my opposite pair and my new adjusted angle C to find side C. So I go my opposite pair equals side C over the sine of my angle I just figured out of C. To get C by itself, I got to multiply by 32.7, and I get 6.4. So I draw this out. It's a side-side angle situation. Notice my opposite pair 15 is greater than my adjacent, so therefore it's only one triangle. A triangle that looks like this, where the opposite side's longer than this. So it's only one triangle. I can just do law of sines. I don't have to worry about two triangles. So I got to find angle B first, so I'll go the sine of angle B over its opposite side equals the opposite pair, the sine of the angle I was given, over my opposite of that angle. Get B by itself, so I'd have to get rid of the dividing by 10, so multiply both sides by 10, then I'd have to get rid of the sine, so I'd do the sine inverse of both of them. It's my calculator ready form, and I'd type it in. And then once you know that angle, you can subtract your given angle 33, your angle B, all from 180 to get your angle C. And then once you know angle C, you can use your law of sines again. We're looking for side C, so we'll go our side over there, angle C, equals our opposite pair side over the angle from our opposite pair. To get C by itself, you'd have to undo dividing by this, so you multiply both sides by this. That's your calculator ready form, and you type it in. And then one last problem, I believe. Here, we draw this out. We can see, and then it's in a side-side angle situation. Well, if it's a side-side angle situation, we have to decide how many triangles it is. Our opposite side of 5 is not greater than our adjacent of 9, so we know it's not this top one. So the next two both deal with opposite and adjacent side of my angle, so I'll throw my opposite, which is 5, adjacent, which is 9, sine of my angle, 50 degrees. Type this in on the right-hand side, and I get 6.89. So Because our opposite is less than our adjacent side of our angle, that's not a triangle. So therefore we don't have a triangle, we can't solve that.